Yeah, guys, am I audible?
Yes.
Okay, cool. So we were on indefinite integration and we have covered the basic formulae part. And now we'll start with the questions. And before starting with questions, I would like everybody to know about some basic rules of integration or some properties of indefinite integral. And these are the same properties, by the way, which we have used in differentiation. So no worries, we are not turning towards something strange. It's very basic thing. So let's start with properties of integration, and then we will be able to solve questions from the first exercise, and slowly we will move towards the next exercise as well. Yeah. So properties of indefinite integration is basically like the connection between, first of all, differentiation and integration. Whatever properties you have studied or rules of differentiation you have studied, these are the same rules of indefinite integration as well. Let's start with the pretty basic ones first. So first thing is that let's say you are differentiating a function, right? And then you are integrating the same function. Right? Let's say consider a function y is equals to fx, right? And this y is equals to fx. Let's say you are finding out dy by dx, and then that value will be something like f dash x. Right? Now, if you integrate f dash x, first of all, you will again get fx. Obviously, plus c would be there. But this is the first point, that if you're integrating a differentiated function, f dash x, then you will reach to the same property. This is the first property. And second is that let's say you are differentiating a function you obtained after integrating fx dx. So there will be some function you will obtain after you integrate fx, right? And then if you differentiate, if you take derivative of that function, so let's say what are we trying to say is, so if you differentiate fx, then the value is f dash x, and if you, let's say, integrate fx, then the value is, let's say, gx, right? Gx plus c, correct? So if you differentiate gx plus c, then you will again reach to fx, right? So this is a two-way. I mean, always, if you can differentiate fx and you reach somewhere, then that's, if you integrate that somewhere, you will reach back to the function fx, right? Similarly, if you integrate this fx and you reach somewhere, and then again you differentiate that somewhere, then you again you reach back. So this is just like fx is here. Either you can go differentiation to this direction, or let's say integration to this direction. So if differentiation of fx is f dash x and integration of fx is some function gx, right? Then if you differentiate gx, you go back to fx again. And similarly, if you integrate f dash x, I mean, I could have written this f dash x as hx as well. You can consider this is a new function, right? But we know that how do we write a derivative form of a function? We just put a dash, right? This means that we are derivating, or we are taking the differentiation of this fx function. So if we integrate this, f dash x, then we will reach back to fx. That is what we are saying. So if we differentiate this, if we first integrate fx and then differentiate it, we will reach back to fx. First two important property. I mean, first important property. And we already knew this, by the way. We have already discussed this, that they are inverse process of each other. Right? Now, let's move on to the second property, which is an important one. And this can be generalized. I mean, there are two properties that can be formed from here. So let me write the whole property once. There will be many properties written in the book, but I don't think you need to remember all of them. Just remember these two things. First, we already knew, we have discussed in the last class that in differentiation and integration are inverse processes of each other. And second would be this property that, let's say there is a constant value. It can be negative, it can be positive, it can be anything, right? But it is a constant. So I'm taking that constant as k1, and there is a function which is f1x, right? Now, if I have another function, okay, let me first write the property, then I'll explain it to you one by one. There can be any number of, functions. Right? I mean, this is quite understandable, by the way, in its explanation. In the formula only, you can easily interpret what is being written here. But if not, then let me help you with the property that we are trying to calculate. Okay, so let's say there are multiple functions, f1, f2, f3, up to fnx. There are n functions, n can be anything, right? And every function is being multiplied with a constant, either multiplied or divided. It depends on the value of constant. One constant can be 4. If the value of k1 is 4, then it is being multiplied, and k1 can also be 1 by 4. So in that case, it can be divided. But whatever this constant is, right? So if a constant is being multiplied, right, k1 with a function f1x, and similarly, a constant is multiplied with every n function, right? So this can be distributed. Integration is distributed over addition and subtraction. First two things. And third thing is integration is also distributed over scalar multiplication. Scalar multiplication, I mean, here what we are doing is that, let's say the integration of f1x was something, right? Now, if you multiply the whole function f1x with k1 and you try to find out integration, then you simply find out your f1x wala integration and multiply the whole thing by k1. Right? So whatever integration was for f1x, k1 times f1x will be same integration for the function. So you just have to multiply the constant value with the integral term. So this is why integration is distributed over scalar multiplication. That means that if you multiply a function by a scalar quantity, it doesn't change the value of integration. You just simply multiply the whole integrated value with the constant you have multiplied the function to. Right? And second thing is that if you are adding or subtracting two functions, you can either do them in a big bracket, or you can simply divide the integration over the two functions, f1x and f2x. Right? Now, so this basically tells you two properties. This can be divided into two properties. First property is that, let's say one function was f1x, or sorry, there was a function fx, and its integrated value was I. Sometimes we write our integration as I plus c. I will be the integrated function, whatever function we will get. Or rather than I am writing the name of this function. Let's say we get some value gx plus c, right? Then if you multiply the whole function by k times, where k is a constant, right? K1, K2, K3, all the numbers are, I mean, all these values are constant. So if k is a constant here, and we multiply the integration with k times, the function k times kfx, then your whole integrated value will be k times k gx plus c. If you multiply c with k, then also it's a constant, right? So I'm writing this as c1. Then after multiplication with k, it becomes c. So there are two things which we can identify from here. And second thing is that if you are adding or subtracting two functions and you are taking integration of them, this you can do by even separating them. Guys, am I audible? Guys, am I audible, everyone?
Yes.
Yes, sir.
Okay, good. So these are two properties which we need to know before we head to solving out questions. Now let's start our basic and see one more thing. We have observed these both of these rules with differentiation as well. I mean, when you differentiate a function fx, and let's say there are two functions fx and gx, and you are adding them or subtracting them, and you are taking the derivatives, then you could have simply distributed the derivative over two functions, right? This was the same property. This was the same property in differentiation also. And again, this was also the same property in differentiation, right? So both of them you have studied in differentiation. That is the same way to approach this. So by first, I can also give you an example. By first, we mean that if you know the integration of sin x, then you also know the integration of 4 times sin x, 10 times sin x, 100 times sin x, whatever. Sin x upon 100, sin x upon 1000. You know the differentiation of all. Sorry, integration of all. And second property says that if you know the integration of sin x and if you know the integration of cos x, then you also know the integration of sin x plus cos x and sin x minus cos x or cos x minus sin x. Anyway, right? This is what we are trying to say. Okay, sure. Let's apply the formula in basic parts first. And I believe that you have written all the formulae in a center page. Please try to remember all of these formula now. This will be only done with the help of questions. So okay, let me also write how can your question be written. So in this case, like this integration is also known as antiderivative. Antiderivative. Better. So antiderivative would be one more word is primitive, I guess. Both of these words means that you have to find out the integrated value of the given functions. To solve for antiderivative or primitive. Is it okay? Shall or simply it could have been written like integrate the following. Okay. Cool. Yeah. First function is given as let's say not a function I'm directly telling you. We need to find out the integration of this. Right? So first of all, we see that there is a division here. We are dividing the whole thing by x, but we have not studied any rule for division. For C, yeah, okay. One more thing I would like to highlight. Yeah, there is a lot of information. One more thing I would like to highlight here is that you have studied the rule for, how to integrate two functions when you are adding them or subtracting them. But we have not talked about what happens when two functions get multiplied, or what happens when one function is divided by another, right? So for multiplication of two functions, there is a specific rule which we will discuss later on. But for division, there is no specific rule. Like there is no quotient rule type thing here. Product rule is there, which is known by integration by parts, but there is no such thing for division. So for division, what we need to do is we need to apply certain tricks, or like just try to simplify the whole function first of all. So there's no specific thing. Okay, so in this case, we have divided the whole function by x, but we can certainly divide the individual term by x as well. So we can write this whole thing as x square by x, yeah, minus 1 by x, correct, with dx. Now this can be written as x minus 1 by x. There are two different functions, x and 1 by x. We know the integration of both of them, and we are subtracting them. So definitely we can distribute the integration like this: x into dx minus integration of 1 by x. Now, can we solve the integration of x squared? Oh, sorry, x dx. It would be x to the power 1, right? There is a rule for x to the power n. X to the power n was x to the power n plus 1. X to the power integration of x to the power n would be x to the power n plus 1 divided by n plus 1 plus c, right? And can someone tell the integration of 1 by x? Anyone? Ln x, right? Log x, correct. Ln x plus c. But see, when we are integrating both of them, then we can only use one c. So x would be x square by 2, correct? This is x to the power 1. X to the power 1 would change to x to the power 2 by 2, right? Minus log x base e, and we can only use one c. We basically want to tell that if there is a constant with both of them, we can add them. So the answer would be x square by 2 minus log x base e plus c. Let's try to find out the simple integration first. Include so. Please solve this one. I will only give you the questions for which you know the formula. There will be nothing tricky. You just need to apply the right formula. Just need to simplify the expression and apply the right formula. So I just want everyone, because the first exercise will be very simple. We are just trying to show you how you can apply the formula. Then we will show you different variations. Yeah, anyone? The answer is what would be this term? Correct. X to the power minus 5 by 6. How can you write this, by the way? X to the power half into x to the power. I mean, I can write this as x to the power half minus 4 by 3, correct? And this can be written as x to the power 2 minus 4 by 3. If you take 4 by x to the power 4 by 3 in the numerator, then it becomes x to the power minus 4 by 3. So this value would be x to the power minus 5 by 6, and this value must be 2 by 3. Now we can simplify this. This becomes x to the power minus 5 by 6 plus 1 divided by minus 5 by 6 plus 1 minus x to the power 2 by 3 plus 1 divided by 2 by 3 plus 1 plus, which is basically x to the power 1 by 6, and this becomes 1 by 6, which basically becomes 6 times x to the power 1 by 6, minus this becomes 5 by 3, becomes 3 by 5. Please feel free to ask me anything, any step which you have not understood. Please try to solve this. We know all the formulas. I would also like to change something in the question. Like I want to multiply this whole thing by 4. And then I want to write 2 here. And I also want to write 5 here. This is 5 into. Please answer for this. Please recheck your question. I've changed some things. I multiplied every term with a constant now, or either multiplied or divided. So check out for the last answer. Does alternating the values, I mean, I have alternated the function, and does that does that change your approach of solving the question? Would you like to comment something on this? Like I've changed the question midway. I have multiplied or divided each term with some constant. Yeah, right. See, multiplying with a constant doesn't change your approach. Whatever answer did you get, whatever answer you get for by solving each part, the whole answer either will be multiplied or divided by the constant that I have done here. So your answer will only change by the scale of this constant. And anyone with the answer? Just tell me the answer directly. I mean, don't write because the answers will be long. So, don't want you guys to go through this thing. Or you can compare your answer with, let me solve the question. So first, there are 4 terms or 4 functions which are either in addition or subtraction. If somebody gets the answer, then please you can raise your hand and I'll ask you. Whoever gets the answer. Okay. So this will be first in integration will be distributed over the 4 terms because they are all in either addition or subtraction. So this can be written as x to the power 3 by 4 dx, and 1 by 2 will be there as well. So I'm taking that 1 by 2 outside. Plus I'm taking 5 outside, 2 to the power x dx, minus I'm taking 1 by 2 outside. This will be e to the power x dx. And then last would be 4 times integration of cos x dx. Okay. So this becomes 1 by 2 x to the power 7 by 4 into 4 by 7. And we can quickly solve the question now. So this becomes 5 into 2 to the power x divided by log 2. Correct? minus 1 by 2 e to the power x, and cos x. Integration of cos x. Integration of cos x. Anyone? Or sin x. So differentiation of cos x is minus sin x, while integration of cos x is sin x. Remember this. Similarly, differentiation of sin x would be cos x. That is why integration of cos x is sin x, right? And integration of sin x would be minus cos x. Okay. Shall try to apply some of the formulae yourself. Okay, let's solve this. Other than solving this, let's now see. We have not, there is no method for multiplication, right? So whenever we see a multiplication or a division, for now, our approach should be to just simplify the whole function, first of all. So this function can be written as, if you multiply sec x with sec x plus 10x, this becomes sec square x, and this becomes sec x plus sec x into 10x, right? And then there is a dx. Correct? Now, do we know the integration of sec square x? If we know the integration of sec square x, then we can, and sec x 10x also, then we can definitely distribute it like this. But if we know the integration of sec square x and sec x 10x, now the integration of sec square x, we do know actually, it should be tan x, and then integration of sec x 10x would be sec x plus. So first of all, first approach, what I'm trying to tell you guys is, what should be the first approach? First approach should be make two function, make a function whose integration you know. This should be the first approach. If we encounter a function, then observe whether the terms involved are such that you know their integration or not. Because if there is not a direct formula right now, then you don't have any other method. You just have to apply direct formula. If you know direct formula for something, well and good, tell the answer. But if not, then there is a problem. So in every question which will be provided to you at this stage would only contain the use of formula. So try to just convert the right form. First approach 0. Like in the fourth example, sec square x and sec x 10x. Both are such expressions for which integral is known. So can you simplify this 1 minus sin x upon cos square x in the form whose integral value is known? Or Okay, how can you write this? Somebody, if you have solved, please.
So
Yeah,
1 by cos square x minus sin x by cos square x.
correct. Then how can we change this to a form?
1 by cos square x you can write as sec square x.
Correct. And we do know the integration of sec square x, right? And this sin x upon cos square x.
Tan x into sec x.
Correct. Tan x into sec x. So I'm writing this cos square x as cos x into cos x, right? Definitely we can write it like this: sin x by cos x into 1 by cos x. That gives same sin x upon cos square x, right? So sin x upon cos x is tan x, and then this 1 by cos x is sec x. तो बेसिकली सी वी आर अभी तो बस हमें इसको सिंप्लीफाई करना है, सिंप्लीफाई करके जो फंक्शन मिलना चाहिए, ये जो एक्सप्रेशन मिलना चाहिए, उसका इंटीग्रेशन पता हो मतलब जितने ऊपर लिख के आए हैं उसी में से कोई ना कोई चीज, एज लॉन्ग एज उसी फॉर्म में इंटीग्रेशन डायरेक्टली हमसे पूछ रहा है हम बता दें। तो बस इतना ही है कि यू जस्ट हैव टू एडजस्ट और यू जस्ट हैव टू ट्रांसफॉर्म द फंक्शन इनटू राइट फॉर्म। Now we know the integration of sec square x dx also, and tan x into sec x also. So this must be what? Tan x minus sec x plus c. Please everybody come to page number 297 on NCERT. Page 297 NCERT. Question number, example 4. Find the antiderivative f, capital F, of small f defined by fx is equals to 4x cubed minus 6, where capital F0 is equals to 3. So basically what this question is saying, it will be around 6 x. The question says the derivative f of small f defined by small fx. Basically, we are saying we could have also written the same question, right? Okay, I will show you one more example of this. But there is a function small fx whose antiderivative, basically whose integration part is capital F, right? So we have to find capital Fx. We are given small fx, and small fx is the derivative of capital Fx. We could have written the same question. Find fx if f dash x is equals to 4x cubed minus 6, where f0 is equals to 3, or these two representations are same, because derivative is given and its integration is being asked, right? Right, please, किसी को भी कहीं पे भी doubt हो, please feel free to ask. Okay, so we're gonna approach this by the book because we already know this, that if we integrate, either we can write it like this. If you integrate f dash x, then we will get small fx. Either you can write for this, you can write it like this. But if you try to approach this via first part, then you will write it like capital Fx is defined like this. This, or rather, I should write it like integration of fx dx is equals to capital Fx, right? Now, we know that the integration of small fx would be this, that integration of, we know the value of small fx, which is 4x cubed minus 6. So basically, if we integrate 4x cubed minus 6, we will get capital Fx, right? Now we can integrate this. This will be, this can be written like this: 4 into x cube integration dx minus 6 into integration of dx. I mean, this is 6 integration of 6 dx or integration of dx, right? And integration of dx. Can somebody tell me what is the integration of dx? If there is nothing, then here is 1. 1 into dx, right? And 1 is what? X to the power 0. So basically, you are integrating x to the power 0. Because x to the power 0 is 1. And 1 into dx would be dx only. Correct, Austin and Chavez both are correct. So integration of dx is x. So this becomes 4 into x to the power 4 divided by 4, integration of x cube, minus this becomes 6x, and there would be a constant of integration when we solve both of them, which is the value equal to capital Fx, which implies that capital Fx is equals to x to the power 4 minus 6x plus c. Now, how do we find out c? See, there is an option given here. There is an option given here that f0 is 3. See, capital F0 is given 3. So that is why it's given that if you put as capital F0 is 3, it implies that capital F0 is what? 0 ki power 4 minus 6 into 0 plus c is equals to 3, which implies that the value of c is 3, which implies that now you have your capital Fx, which is the antiderivative of small fx, and the value is x to the power 4 minus 6x plus 3. We needed to find the integrated portion, and we can also use the information that capital F0 is equals to 3, which will help us in deciding the value of C. Okay, good to go. The next question. I'll try to solve some questions. Let's see. Give me a minute. Oh, it's been done in this exercise. No, it is not. Only done in the first question. Okay. So let's leave question number 6 for now. Okay, this is method of inspection is also given, but I mean method of inspection is not necessary. This not at all necessary. I mean, we don't need to actually do this, but for your own understanding, if you want to do this, this is a very good method. Method of inspection basically tells you how to identify the integration of a function by using the differentiation formula, right? So let's say, for example, let's try to solve one question. Just you need to differentiate using method of inspection. The method of inspection says that rather than thinking about integration, you try to think in terms of differentiation. In terms of differentiation, man, by if you are integrating sine to x, right, then this would be a function. This would be a function. If you integrate to this function, so this would be a function where if you differentiate, you will get this sine to x, right? So you think about in the terms of what should be the function whose differentiation is sine to x. Rather than thinking of the integration of sine to x, you think like this, that what should be the function whose differentiation is sine to x. So for getting the differentiation sine to x, I must I mean, the function must be cos. The differentiation of cos is only sine, correct? So what I'm doing is I'm starting with cos 2x. So differentiation, let's say the answer is some function gx. It must contain cos as differentiation of cos function is sine, correct? Let's say the answer is, consider the answer is gx. Consider the answer is gx. Then gx must contain cos as differentiation of cos function will give you sine, correct? So what I'm doing is try with assuming gx as cos 2x. Let's try to differentiate cos 2x, right? So cos 2x would be, to differentiate this function, cos 2x would be minus sine 2x first. Cos is minus sine, correct? And then you will differentiate 2x. So differentiation of 2x would be 2, correct? Now you want your differentiation to be sine 2x. Rather than minus 2 sine 2x, you want your differentiation to be only sine 2x, right? So what you can do is, you can take this minus 2 to the left hand side. I mean, what is g dash x? G dash x is differentiation of gx, right? So if I take minus 2 to the left hand side, this becomes minus 1 by 2. Differentiation of gx is equals to sine 2x, right? So if you differentiate minus 1 by 2 gx, you can take minus half inside, then the answer is sine 2x, which means that if you integrate sine 2x, okay, I'll also show you one more thing. we can actually, you know what, we can actually reach to our answer from here only. We can actually reach to our answer. How? I can also divide this d by dx. If I want to convert this expression into integration, what I can do is, see, I can write this as d minus half of gx. So in d by dx, I can take dx to the right hand side. From d by dx, I mean, this is not like it happens mathematically, but the approach is same. The intuition is same. But this actually does not happen like this. What I'm trying to show you is not correct mathematically, but sorry, is not correct conceptually, but mathematically you will get an essence that what we are doing. So I'm taking this dx to the right hand side. Now, as the dx is in denominator here, it will reach to numerator. Correct? So this can be written like this. Now, if you integrate both sides, what happens? What happens is this, that you write it like this, integration of d minus half gx, and here you get integration of sine 2x dx. This was the thing that we wanted to find out. And what happens with this? This becomes 1. This becomes 1. And this is just minus half gx. You know the value of gx. You have considered some value for gx, which was cos 2x. Hence, integration of sine 2x dx is minus half cos 2x, obviously, plus c. Right? So the important point was integration into differentiation are inverse properties of each other. So if you just multiply integration into d, it becomes 1. But if you multiply integration into dx, that becomes x, because that is not d. If you multiply integration into d, this is integration into derivative. They both are inverse processes to each other. But d and dx are not same. Remember this also. So this is method of inspection. I have just told you for your understanding part. You don't need to do this part like, I mean, for exams. For exams purposes, this is not required. So I believe you will be able to solve most of the questions from exercise 7.1 now. Now let's move on to the next part. Try out the first exercise today. Okay, this is your homework. I'm writing it here. Try out your homework will be exercise 7.1 from inside. Guys, please try to solve every question from each exercise during the classes itself. During the course of classes. क्योंकि अगर अभी नहीं करोगे फिर डाउट्स आएंगे, फिर होगा नहीं यार ये चैप्टर. It won't be done until your exams happens. So this will be very difficult to deal with, because there are 3 chapters, like 1.5 month, next 1.5 month depends on the chapter itself. That is why please try to solve every exercise which is given as the homework in the class. So please don't miss out on the exercise. Okay, now let's move on further. This exercise will teach you the basic formulae, and you will be able to remember some of the basic, this 10 to 15 formulae for integration, which will be required during the whole chapter. So after this, let's try to work out how do we approach integration. What are the different methods that we can use for integration, right? So in particular, there are 3 methods, right? And the first one is the most important method. First is integration by substitution. A very important method. I mean, most important method among the all of 3. There are 3 methods, but among these 3, integration by substitution will be the method which we will mostly use. And this method will be used in second and third also. I mean, without using method 1, there will hardly be a question which can be solved. I would like to tell you this. Integration by substitution will be a form which will help us massively in solving integration. So, and the second part is integration by parts, and third part will be, in fact, I'm strictly talking about indefinite integration by parts. So second would be integration by partial fraction or by parts. You can do anything. This we will learn what is partial fraction and how we can integrate a function using partial fraction. And then third will be integration by parts. I have just described this. What was this? So this is nothing but product rule for integration. If there are two functions whose differentiation or integration we know, right? Rather, leave that thing. How we approach this will be a different thing. We will tell you in the chapter in the topic itself. But for now, you can just remember when two functions fx and gx are multiplied, how do we integrate fx into gx? That will be taught in integration by parts. So this is nothing but product rule for integration. And today we will start with integration by substitution. So I don't know how much we will be able to cover integration by substitution, but this will go on for quite some time now, because integration by substitution is the basic part of integration. If you're not able to catch integration by substitution, there will be a problem in integration. The first part is integration by substitution. Now, see, as I have told you in the first exercise, that you go through the first exercise, what will you get? That you will be able to remember all the formulae which we have solved in the last class. And I believe that some of the formulae should be remembered by now. But if not, then you will remember all the formulae, because there is direct application of formulae in first exercise, right? Now, what happens if we get a function whose integration we don't know? What happens if we get a function in integration whose formula we don't know? So this is the very important part in integration, because most of the question will be such that you don't know the formula directly. If you know the formula directly, फिर तो कोई बात ही नहीं. Problem ही सारा ये है यार integration का, that we only know some formula, right? And we should convert whatever expression is given to us in those forms. If we are not able to convert that expression into the given form, into the formula part, तो मैं integration नहीं कर पाऊंगा. I don't know about the integration of each term. In fact, there are functions whose integration is not known yet. There can be functions whose integration does not exist. So we don't know that whether we'll be able to solve anything until we don't know we are able to convert that expression into a form for which formula exists. So if there is a formula for something, then we will be able to integrate that. If there does not exist any formula, then we have to change that expression. We have to convert that expression. We have to transform that expression into an expression for which we know the formula. So I'll show you some of the basic example for this. You can go to page number 300 on NCERT, and they have shown you how they are using the substitution. So for example, okay, I'll also explain this concept. For example, I want to find out an integration for a function fx, right? And let's say the integration value is I. I mean, I is a function of something I don't know, but I'm not able to find out I. So, okay, let's approach it like this. If I want to integrate fx, then fx should be a function which can be fitted directly into a formula. For example, if fx is sin x, I know how it works. If fx is x to the power 7, I know how it works. If fx is log x, I also know that, right? But what happens if fx is log 2x? I know the integration of log x, but I don't know the integration of log 2x. I won't be able to solve log 2x right now. Similarly, I know the formula for sin x, but I don't know the formula for sin 4x. If you multiply x with something, there is a problem, right? Then all such forms, right? If for these don't know the formula, we can only integrate something if we know the formula. For log x, a formula exists, we know the integration of log x. Oh, sorry, we even don't know the formula for log x. Yeah, sorry, my bad. Yet we have not even described the formula for what happens if you integrate log x. You can't even integrate log x, guys. Not log x, not sin 4x, log 2x तो भूल ही जाते हैं. ये तो बहुत बात की बात है. My bad. तो ये बहुत बात की बात. We don't even know the formula for log x because we don't know the formula whose differentiation is log x. That is why we don't know the integration of log x. If you know a formula whose differentiation is log x, then it is easy. What if fx is equals to log x or fx is equals to sin 4x or fx is equals to e to the power 4x? E to the power 4x, don't know. E to the power x we know. E to the power 4x don't know. No. So what do we do in these cases? We simply substitute x. Substitute. So right here like this. If fx is an expression whose integration is not known directly, then we need to convert fx or we need to transform fx into form which can be integrated. And how do we do that? Use substitution. Substitution means replace your x with some function gt. Replace your x with some other function gt. And then if you replace x with gt, you're basically changing your variable. Your variable was x, but you're changing it to t now. Right? For example, you can take x as sin t. Or you can take x as, for let's say, e to the power t. Or you can, let's say, take x as log t. You can take anything. These are the examples. So take x is equals to gt. Take x with, replace x with some another function. How would you do that? We will tell you how to approach, how to assume this function gt. We will tell you. But what effect will it make on your original integration? First, understand that. So you're changing your variable x to t. It means that you also have to change dx with dt, right? Now that can be find out like you differentiate the whole function in terms of t. So if you differentiate x with terms of t, this becomes dx by dt, and this will be g dash t. If you differentiate this gt with respect to t, differentiate with respect to t, you want dt. In place of dx, you want dt now. because you are changing your variable x to t. So that is why we are differentiating with respect to t. So dx by dt becomes g dash t. And from here, you can take the value of dx as g dash t into dt. G dash t into dt. So you can use this in your first equation, which was this. Right? So you put, actually, this is not second, this, let's call it as third.
So for this, you have to do first derivative. So you have to derivative, then integrate it.
Sorry.
So for this method, first you have to differentiate it, then integrate it.
Yes. I mean, to find out the integration of fx, what we will do is we will replace x with gt, some function gt, and then we find dx. We have to replace dx also. So in place of x, we will use gt, and in place of dx, we will use g dash t dt. How is that obtained? You can observe, you can see that here. So we will use second and third in first. Your function becomes, your I function becomes f of x. X is now gt, and dx becomes g dash t into dt. So instead of solving fx dx, you will solve this one. Solve this. Okay, let's try to see how we can apply this. Is it done for everyone? Cool.
Sir, can you
Are you done? Okay, tell me when. Cool. So let's try to see the application of this now. So your angle M is, angle X is changed with M, where M is a real number, except 0, right? So M is a constant. Now we do know the integration of sine X, but we don't know the integration of sine MX. Basically, and if our X is multiplied with some constant, how should we approach this? We know if this has been multiplied with 4, there is no problem, right? In that case, we would just take 4 outside, and we can integrate sine of mx, that will be done easy. But if your x is multiplied with a constant, then that is a problem. Sine mx will be dealt differently. Now, how to deal with it, understand it. So we'll use substitution. Substitution how? That, okay,
X is equal to G.
x is equals to gt, but what is gt? Gt is a function of t, right? Sorry. So x will be
Yes,
like,
sir.
so tan t, or x will be something like this. You have to assume x like, okay, वो तेरे को छोड़ दे, भी इसको छोड़ दे, पहले यहाँ पे समझ. So what's the problem here? Problem here, m. If m would not have been here, we would have easily calculated the integration of sin x, right? What is the problem? Problem is m. Now, if I substitute this whole mx with a variable t, right?
So M is a constant, right? So we can take it out. So we can integrate.
Not outside of the sign. I mean, sine 2x, can sine 2x be written as 2 sin x? No. This 2 is inside sign. So we can't take it outside of sign. Sine 2x is 2 sin x cos x, if you remember. This is double angle formula. So it can't be 2 sin x. That is why the problem is m. Because of this m, we are not able to use our direct formula. So that is why what we are doing is we are substituting this mx with a variable t. Because if this becomes sine t and we have dt, then we do know the formula. Sine t dt can be integrated. No problem. So if we are putting this mx as t, right, then I can differentiate both sides with respect to t. So this becomes m into, because m is a constant, right? So if you differentiate x with, differentiate both sides with respect to t. So this becomes m into dx by dt, and differentiation of t with respect to t is 1, which means that the value of dx is nothing by dt by m. So remember two things. First, what should be the substitution? What should be the substitution? What should be the substitution? This was substitution. Put or substitute. And write it like substitute mx is equals to t. So try to find out that expression which needs to be substituted. And substituted expression, I'll tell you some things about this. You will gradually learn how to substitute. You won't learn the art of substitution in a day. But let's first try to encounter this using simple examples. So first is, if you see a direct problem, try to substitute that value, right? In this case, mx was a problem. So I substituted mx as t, right? This was the substitution we made. So this is my first term. Then after substitution, if your substitution is correct, how would you know? You would know after some time. I'll tell you how would you know your substitution is correct or not. There are various checks that we can make on our question, which will tell us whether we are heading into the right direction or not. So mx, after substituting mx as t, so basically you are changing your variable x to t. So that means you need to find out the value of dx. You will substitute dx with dt, which means that both sides differentiate with respect to t. Always. This will happen always, which will give you the value of dx in terms of dt. Use these two equations to solve your first question. How? 4 can be taken outside. This sine mx can be written as sine t, because mx is t. Then your dx can be written as dt upon m. What is m? M is a constant, and m is dividing the whole thing. So you can take outside. So it becomes 4 by m sine t dt. Now, this is your first, this is your second check. First check we would understand in some time, but this is your second check. Second check is that if you are able to convert your function into an expression whose integration part is known to you, then you are good to go. We can directly integrate sine t here. Sine t dt. If you are integrating sine t with respect to t, what's the answer? Minus cos t. plus c. We know the integration of sine t. So first check, I mean second check is, or final check is कि अगर आपने ये substitution लगाया तो what's the point of substitution? The point of substitution was to transform the function, the original function, which was sine mx, into a function which can be directly integrated. So we have transformed sine mx dx into sine t dt, and sine t dt is direct answer. Right now, the original answer, the original variable was x, but you have substituted x, right, with t. So in the final answer, you just substitute it back. So this 4 sine mx dx can be written as 4 by m, or rather minus 4 by m, right? Minus 4 by m into cos t. Now this t can be written as mx plus c. So use your original values back, original variables back into the final answer, because you have been asked the question in terms of x. Why did you use t? So that you can find out the integration. Because we did not have a direct formula for sine mx. Right? You will gradually learn how to use substitution. So we will understand more about it in the next class on Wednesday. Just try to complete exercise 7.1 and also try to read out so this would be my advice to you before coming out for the next class, that try to solve first exercise 7.1 and try to read examples from NCERT before 7.2. Right? Okay. Do we have any questions regarding what we have done today? Any problem, any doubt in any question? Okay, cool. In that case, we will meet